I guess first with the knot.
Okay, good. That would be a good place because that's where all the tensions are going to sum to what?
Okay.
0. So if we start with a knot and we draw a free body diagram.
The first tension, I put the one on the left, T1.
Okay, that's fine. We can do that. So here is T1.
Mm-hmm.
And then I guess this would be T2.
Mm-hmm.
And then what, is that all?
And T3.
Okay, which is also equal to what?
The weight of the box.
Right. So let's just put weight there. What other conclusions can you, or assumptions can you make?
That is at rest.
At rest. So the acceleration would be?
0.
Good. So we'd be using the first law. If we set up our axis like this, what happens is our y is purely in the direction of the weight. And then we can say T3 equals weight, eliminate that out of the equation, and then just look at this. So you should be able to just, without even doing the sum of the forces on this thing, and say to yourself, okay, whichever one's going to be more vertical is going to carry more of the load.
Okay.
Okay, so of the two, which one's more vertical?
T1.
Good. So that should be carrying more of the tension. But let's prove it quantitatively. Let's take a look, and we're going to say the sum of the forces in the x
equals T2 x minus T1.
So if I do that, if you remember, alternate interior angles are congruent from geometry days, this would become 60 degrees because this is a parallel line with the ceiling, right? And this is 60 degrees. So these are alternate interior angles, and they're congruent. So that means this is 60 and this is 40. You okay with that? All right. So then, based off of that, we should be able to break them down in our components. So what is there aren't any red colors that aren't feminine? Jeez. All right. And then do we want to make that positive or negative?
Negative.
Right, because it's to the left. And then the other one's going to be the positive one. So T2, that would also be cosine if we're doing the x. Are you with me or not? And then that's going to be what?
Equal 0.
0. And theta 1 is 60. It's going to plug in. So what we can do is add that over. Okay. Let's get some numerical values associated there. What's the cosine of 60?
1/2.
Good. And then what's the cosine of 40?
I don't know.
Come on, you don't know these things? So here we have
0.766.
Good, that's what I got too. So T2 is and then 0.766. So what I'm going to do now is I'm going to make it into a ratio. Okay. From one side or the other. Since I've got decimals going on the left, let's divide both sides by that 0.766. So times 2 is 1.53, right? So what I've just found out is tension 2 is tension 1 divided by 1.53. So which one of those is bigger based off that statement?
Wait, hold on. Tension 1.
Tension 1. Tension 2, fraction of tension 1. Okay. Had this been a number up here, then tension 2 would be bigger. Does that make sense? Okay. Analyzing it, though, by saying the more vertical one should be an easier explanation. Sometimes they do want quantitative questions. Okay, so that was part A. You got that down? All right, let's close that.